if you have to continue, you should make sure that you get the equation correct. If you get the equation wrong, then you are doomed. You
Mm,
can't do anything about it again. So this will simplify it to 11 meters. 11 meters. And I think the rest should be very easy.
mm,
That is for my opinion. Assuming the sprinter runs the rest of the race, so he has already run 11 meters. So I'll be left with I think 89 if my math is correct.
yeah.
The rest of the race will be I think 89 meters. You continue with the Suvat. Hey, okay. So assuming the sprinter runs the rest of the race at the speed he attained after 10 seconds, find the total time it takes him to run the race. So what do you think? What do you think this is going to be?
Um. Okay. For the Suvat thing, like how I'll write it.
Mm-hmm. Is there
Okay.
any acceleration over there?
Acceleration. No. Right now, what they gave us was velocity,
Mm-hmm.
and they told us that assuming the velocity he had after 2 seconds is the same he uses throughout the race. So that means my initial and final velocity will be 11.
Yes, which means that acceleration is
You said
which means acceleration is
acceleration will be 0. Oh, yeah.
yeah. What did you get now?
I still got the 8 point. This time I got 8.09.
8.09.
Yes, but I didn't involve acceleration. I just used my distance, initial and final velocity to try and find time. So I used the half v plus u all times t.
Okay, Derek. How many meters is what's the name? Is left to cover?
89.
89. And what was the speed? What was the speed of the person after 2 seconds?
After 2.
Did you calculate the speed of the person?
Yes, that will be 11.
11.
Yes, if you use v is equal to u plus 80.
V equals U plus 80.
Yes,
So
that's 5.5 times 2.
V equals U plus 80. This is going to be U to 0. A is 5.5 times
Yeah.
2. This is going to be 11. Okay, so we left with 89 meters to travel, and we have to do that. And the speed, this is the distance. Distance is equal to speed times time. Do you remember?
Yes.
Speed times time. So I can say that time is equal to distance over speed. So 89 divided by 11, what do you get?
Yes, that's the 8.09.
8.09. And what did the book get?
It got 10.1.
10.1. Let's take the question again. Assuming the sprinter runs the rest of the race, we are saying after 2 seconds, find the total time taken to run the race. Yes, Kelvin. Hey, I said Kelvin. Why? I'm so messed up today. Uh, Derek,
Yeah.
you got 8 point what?
8.09.
8.09. That is very good. That was for the rest of the 89 meters. But the guy has already used 2 seconds to run the race already. Are you getting me?
I'm
The guy
still the other time he takes to run.
ran the entire race. Find the
Okay.
total time it takes the runner.
Didn't
So
they
it's
say find the other time? Oh,
find
I
the
total.
total time.
I copied the wrong question.
Oh. So the total time becomes the summation of the previous time and the new time calculated. So it's going to be the 8.09 you're talking about
Yeah.
plus 2 seconds. That should give you 10.
Yeah.
10 point something.
Yeah. Point one. Okay.
Okay. So that is that one. Okay. So just take your time and solve this one as well. Okay. Just take
Okay.
your time. Fine. Let's get on with what we have to do today. If you've got issues with that, also let me know so that we tackle it. Okay.
Yeah.
Okay. So today we're going to finalize everything with kinematics. It's very good because this is going to be the end of two main topics. Yes. Okay. The last branch of kinematics has got something to do with free fall, vertical motion. So far we've been doing horizontal motions. We're going to look at vertical motion. So vertical motion falls under three categories. Three. One, an object is projected from the ground, a level ground, upwards. That's case one. An object projected from a level ground. Case two, an object is projected above a level ground. So if there's a ground, the object is projected at this point, upwards. So upwards this way. And case three, an object is dropped from a level above the ground. So this is coming down. So this is going up. This is going up. So these are the three main cases you come across when you are dealing with this type of vertical motion. So let me take it again. The first case would be a case where the object is projected from the ground, a level ground. The second case, this is projected above a level ground. So let's say at height h above the ground, the object is projected upwards. And finally, the object is dropped from a level above the ground. Is that okay?
Yeah.
So these are the three main cases you come across when you're dealing with this kind of vertical motion. Now, in this kind of vertical motion, we're dealing with a nice form of acceleration, which is gravity. We've got gravitational pull. That is the main source of acceleration of this. That is the acceleration the particle is going to attain. Now, in which direction does gravity act?
Downward, like towards the
Downwards.
ground.
Downwards the ground. It's very good that you know this one. This is the direction of gravity. So, whenever you're tackling a question, please take into consideration the direction of gravity. It's very, very important. As you know, these things are forces, and they are vector quantities. Vector quantities direction is actually a main factor. So if gravity acts downwards, and we know gravity, we are approximating it to 10 meters per second squared, which is not actually the exact figure.
Mm.
But as you go on in your study of mathematics, you start to use a more accurate figure for gravity. So for the meantime, we're using the 10 meters per second squared. If an object is going upwards, this is going against the direction of gravity, right?
Yeah.
So in this case, this is going against the direction of gravity. So with this one, because it's going against the direction of gravity, it's moving in the opposite direction. What do you think we're going to do to the value of gravity?
Oh, it will be negative.
It will be negative. The negative just shows the direction. Are you getting me? It's just like what we're doing with the velocity when we are moving in the opposite direction. Velocity is negative. Displacement, you are moving in the opposite direction. It becomes a negative distance. Those kind of things. That is the same thing that is happening over here. So with this one, if the particle is going against gravity, you should take note that the acceleration is going to be negative 10 meters per second squared.
Mm.
So in this first instance, the acceleration is going to be negative 10 meters per second squared. You don't need to memorize this. It should come to you naturally. You don't need to memorize this one. Similarly, this one, the second case, the direction of motion is going upwards. So again, the question is it going against gravity or is going for gravity? In this case, it's going against gravity. So the value of acceleration is still going to be a negative value. In the third case, we are dropping the object and the object is actually coming down. So again, is this going against gravity or for gravity?
It's going with gravity, so positive. Yeah.
So the acceleration is going to be positive.
Yeah.
So that's one thing you need to know when it comes to free fall. And I actually like free fall questions because I know one of the value automatically. I don't really need to stress myself to think about any value because I know the acceleration is going to be either 10 or negative 10. And also, direction of motion is very important. Well, at this part, it won't really do much. It won't really do much, but when you start doing laws of motion, connected particles, the direction of motion will really, really come into play. It will come into play, all right, but it won't be like the way it will come into play when you're dealing with the laws of motion. So that is one of the things you need to know about this. The second thing is we are not in space, so there is this saying that what goes up comes down. I
Yeah.
don't know if you've heard of it before.
Yeah.
So you project a particle upwards, definitely it's going to come down. Definitely it's going to come down. So again, if I'm to refer you to another topic that is work energy and power, you realize that when a particle is moving upwards and there is no extra force acting on the particle, it will get to a time that the particle will stop moving. So we call this the turning point or the maximum height. So the maximum height reach, as the particle is actually moving upwards, the speed is reducing. That's why it gets to a point that it can't go up again. So when it can't go up again, we take it that it has gotten to its maximum height above the ground. So when it gets to this place, there is no speed over there. So at this point, what can you say about velocity? At
It will
maximum
be
height,
zero.
velocity is zero. So velocity is equal to zero. So when the particle reaches its maximum height, the velocity is zero. Okay. So that is one thing to you need to know. So the rest is actually based on Suvat, and I can say that I'm done teaching you the vertical motion. So what we need to do now is to solve questions. This time there are 13 questions. We solve as many as we can. If we don't finish up, we continue the rest as an assignment. Is that okay, please?
Yes, sir.
Okay, so the three main things, three scenarios. You should know the three scenarios. You should know the direction of motion that affects the sign of acceleration, and also you should know that at maximum height, velocity is zero. So these are the three basic things you need to know when it comes to vertical motion. So let's see our very first question. Free for question number one. Free for question number one. Okay. So that's our very first question. Um, let's see where we're going to put this one. Is it category one, category two, or category three? A book falls from a shelf 1.8 meters above the floor. Find the speed with which the book strikes the floor.
Category three.
Category three.
Yeah.
Okay. Okay. So this is a particle dropping from a level ground. Sorry, dropping to a level ground. So this one. Why is my lines line? I don't know. They're not straight. It's as if like I've taken some alcohol, and I don't really take alcohol. Okay. So yeah. Now let's set up a Suvat with this one. Suvat. Now we know what the distance is. It was given to us. It's very clear. It's 1.8. The distance is 1.8 meters. What of the acceleration?
Acceleration. It will be 10 meters per second
10
square.
meters per second square. In some boats, when you're talking about free fall, they don't actually use acceleration. They start using G. G
They use
representing
what gravity like.
gravity. Yes. I would like to stick to the Suvat. That is the A. When I bring G in there, there is no vowel over there. Okay, there'll be vowel. That is the U, but it won't make it sound nice.
Mm.
Just imagine SUVGT. So let me stick to the Suvat. It's the same thing. If you see the gene, they're just implying that it's a free fall question and
Mm.
the acceleration is actually the acceleration due to gravity. But if you use the A2, you're not wrong. Now, let's see, we've gotten two values. And so far, you should know that to solve any kinematics question using this kind of algebra, Suvat equations, you need at least 3 points,
Yeah.
three values given. So what do you think is the missing value?
Initial velocity 0.
What initial velocity is zero. Good.
Mm.
The initial velocity is zero. So at this point, you can find anything. I think we've gone past the stage where there should be a problem for us. I think we can use v squared is equal to u squared plus 2as. V squared is equal to u squared plus 2as. And u, the necessary substitution, v squared is equal to 0 squared. I did not write that one. Plus 2, the a is 10, and the s given as 1.8. So basically, we've got 2 times 18, which is 36, and v is equal to square root of 36, which is
So
6 meters
6. Yeah.
per second. So the velocity at which this hits the ground is 6 meters per second. Is that okay?
Yes, please.
So that's very easy, a simple question, and that is very easy. All the questions are actually in the book I gave you, so don't worry.
Mhm.
All of them are there. Let's see if we can get another question. Okay, so question number two. A stone is dropped from 48 meters above the ground. Find the time it takes to hit the ground. This kind of questions, they are actually concept building questions. So if you grab the concept, we move on to the past question. The past question is they are a little bit complicated. It's not that they are the way they put in the question. You need to put in a little reasoning. But this one is a textbook question, so it's for concept building. Later on, we prep ourselves with the past questions. That will be on Thursday. On Thursday, we prep ourselves using the past questions. Then on Saturday, I'll come over. We do the laws of motion. Then by the time you go to school, I would have finished up momentum with you as well. It's so bad that I won't be taking you this time. Yeah.
Mm.
The person going to take you is actually very good. So,
Mm.
huh. Okay, so let's solve this one. A book is dropped from a level 48 meters above the ground. So 48 meters. Let me just draw my ground wall. I don't have. Okay, so this is 48 meters, and this is the book. Yes, that's the book. This was dropped from a level 48 meters above the ground. Find the time it takes. And the way the question looks, is as if like you've been given only one value, and all of a sudden, um, you're finding things.
Yeah.
So Suvat again. Uh, the S given is 48. The U given is 0. It wasn't given back. Common sense should tell you that it's 0. And acceleration due to gravity over there is 10. We can by using S equal to UT plus half AT squared.
Mm.
And S is equal to 48. And U is 0. Time is 0 plus 1 over 2. Acceleration is 10. And T squared, that's what we're looking for. This is 5 divided by 48 divided by 5. So I think T will equal to the square root of 48 divided by 5. And that
That's
should be, oh yeah,
3.1.
3.1. So the time given is 3, time looking for is 3.1 seconds. And that's for that question. Is that okay?
Yes, please.
Okay, good. Okay, so the next question, this is the next question. A stone is dropped from, I think you should be able to solve this in about a minute. So solve this in a minute.
Okay.
Let's see what you're going to get. A stone is dropped from the top of a cliff and falls to a level ground. If the stone is the ground with a speed of 18 meters per second, find the height of the cliff.
So 16.2 meters.
Okay, 16.2.
Mm.
Okay, so this one I'm not going to do any drawing. I'm just set up my Suvat. So setting up the Suvat, but it took a lot of time. I don't know why it took a lot of time for
I,
that.
I copied the question. Mm.
Okay. Okay. The speed, the final velocity given is 18. The initial is 0. The distance, that is what we're looking for. That's acceleration is 10. So I can use v squared equal to u squared plus 2as. Please, you need to know all the five. Okay, you need to know
Okay.
all the five. If you know lesser than five, you get yourself into trouble. So at times you need to pass through finding D and finding S. But if you know all the five, you know each and every one has got its own limitation. I think we figured that one out at that
Mm.
time. All the five has got its own limitation. So if you know all the five, you can move faster. 0 squared plus 2, the acceleration given is 10, and the S is that. So 18 squared, is it 361? I don't know. I forgot. Is it 361? Question for me, is it 361?
324.
324.
Mm.
Wow. How did I miss that? Hmm. Okay. Anyway, yeah, you do the manipulations and you should get something nice.
Mm.
What was your S, please?
16.2 meters.
16.2.
0.2. Mm.
Okay. Check 19 squared for me.
261.
19 squared.
Yes.
261.
Yeah.
Okay. Okay.
No, 361. Sorry, 361.
Yes.
Mm.
So it was actually 19 squared I was talking about.
Mm.
Yeah, a ball is vertically thrown. Hey, I'm even reading backwards. What is wrong with me today? A ball is thrown vertically upwards with a speed of which case of Suvat's vertical motion is this? You don't
A
need to
ball
memorize the case
thrown
study. You don't need to memorize. But which scenario is that? A ball is thrown vertically upwards with a speed of 5 meters and travels freely under gravity. Find the velocity of the ball after 2 seconds and the distance the ball has traveled from the start
I
at
think
the time.
it will be scenario 2.
No, it's scenario one actually. From a level ground.
Where is that?
Scenario one, they didn't give you a level
Where
above
did
the
they
ground.
see from? Where did they see from a level ground?
They didn't see a level ground though. They didn't say anything about the level ground, but they didn't also tell you that it was thrown above. If they were talking about something like if the ball was projected above a level ground, it to be stated, okay, a ball is one projected with a speed of let's say 5 meters per second at a level ground above like 1.8 meters above the ground, those kind of things. It will be stated for you. But if nothing is stated, then we take it that it's projected from a level ground. So there is level ground, and this was the speed at which it was projected. The speed it was projected was 25 meters per second. So let's set up the Suvat. Okay. Okay. What is going to be the values over there? I think I
Um,
can time. Time is 2. What of the final and initial velocity? Which one is which?
Initial is 0.
Initial is 0. And that is where you get it wrong. This was projected with a speed of 25 meters. Okay. So this was projected. The initial speed count is 0. The reason this can't be 0 is that if there is no speed, how can it even go up? I
Um,
get if there is no speed, how can it go up? It's different from something being dropped. If it's being dropped, it can be 0. But if there is no speed in this case, the particle can't go up. So it was projected with a speed. It's going to start off with a speed. So in this case, the speed is 25 meters per second. Is that okay, please?
yes, sir.
Okay. Now, gravity, what of the value of gravity?
Um, that one will be negative 10 meters per second.
meters per second squared. So earlier I was like, when an object is going upwards, it's actually reducing speed. The speed is reducing.
Yeah.
This concept will be explained to you when you are doing work energy and power. The concept will be explained to you clearly what they're using kinetic energy and those kind of things. But looking at this, even the Suvat should explain that concept. We've got the acceleration to be negative 10 meters per second squared. What does it mean? Acceleration to be negative.
And that means the speed of the ball will reduce, will start decreasing.
It's relation.
Yeah.
The value is negative, so it implies deceleration, and deceleration implies that reduction in speed. So even the Suvat explains itself. But a more in-depth explanation will be given to you when you are doing work energy, using kinetic energy and other things. So it's fine. And that would be called a loss in kinetic energy. Okay. You're going to enjoy your mechanics. Trust me. It gets interesting when you go up.
Mm.
And unfortunately, I'm not taking the further mechanics to uh, these people.
Mm.
Okay. Okay. So let's do the manipulations. We can find the distance using s equal to ut plus half at squared. Ut
Okay, you're finding distance first. Okay.
plus half at squared. S now becomes U is 25 and T is 10. So T is 2 actually, sorry, 25 times 2. That's 1 over 2. A given to us is negative 10 and the T is 2 squared. So do the calculation for me and that should get you something.
Mm.
Hey, stop the noise! Stop the noise!
That is that right.
Yeah. You want to? I'll wear my headphones. So don't. I'll wear the earphones. You can come.
Okay. So what is the value for the S? It should be 50 minus 20.
It's 30.
That is 80 meters.
Mm.
We're told to find what else? Find the V.
Velocity.
But I can now use my favorite V equals U plus 80.
Mm.
So V is equals to U plus 80. I think this is the first time I'm using it.
Yeah.
So U is 25 plus uh, 10 multiplied by 2. And the final number is T. The
It's
velocity
fine.
at that point will be 5 meters per second. Right. Sorry, 5 meters per second. So that's the fourth question. We've so far tackled 3 questions on scenario 3 and a question on scenario 2.
Mm.
Sorry, scenario 1. Okay, let's see this one. For the ball in question 4. Fine. Okay, so this is actually linking to the previous question. For the question 4, find the maximum height reached by the ball and the total time taken to return to its position. This is interesting. So you've got the details of the previous question, right?
Yes.
Okay. Let me the keywords over there. The time was correct. The acceleration was negative 10.
Yeah.
The something was given as 25. The initial velocity
Yeah.
was 20.
That's the initial velocity.
Yes. So with this question, what do you think the velocity at the maximum height should be?
0.
0. Okay. At maximum height, velocity is 0. So you can use any one that contains s. But no. The time in this case won't be 2 because the time was given for under 10. The time is the time we use a tool to calculate the distance the particle has traveled in the 2 seconds. That
Yeah.
doesn't mean that the total at the maximum height the particle will have traveled 2 seconds.
Mm.
Okay,
So you have
so
to use just these three.
we can use this story to find s v squared is equal to u squared plus 2as. V squared is 0 squared, u squared is 25 squared plus 2a is negative 10 and s. So you can do your manipulation. 25 squared should be 625. So negative 625 over negative 20 is
Um, 31.25.
31.25.
Hmm.
So let's find the time it takes the particle to get to get to the maximum height. So this is where the particle was projected, and it went up to this level, to this level. So at this level, the particle was 32.5 meters above the ground. Let's find the time it actually takes the particle to get to this one.
So where did you get the 32 from? Point
Oh, was
five.
one? Oh,
Yes,
sorry, it was
31.25.
31. Correction. 31. How can I write 31 and write 32 over there? Please. Okay, so that is 31.25. 31.25. And then 31.5. 31.25 meters. Okay. So let's find the time it takes the particle to get that. We just with that maximum.
Okay.
Or we can use b equals u plus 80. That should be very easy.
Yeah.
0 is equal to 25 minus negative 10. So the answer should be 2.5 seconds, right?
Yes.
Okay, so it's taking the particle 2.5 seconds to get to the maximum height. But the question is saying that find the total time taken to return to its starting point. Find the total time taken to return to its starting point. So the ball was thrown upwards and go to the side with what's the name? With a time of 2.5 seconds. So it took the
Hmm.
particle 2.5 seconds to get to the maximum height. Now let's find the time that is going to take the particle to get to the side. Actually, I know it's going to be 2.5, but because we are beginners, we let's assume that we don't know that it's going to be 2.5. So at this one, this gives you another form of Suvat, or let me say another scenario. This is a scenario where the object is projected downwards from a level ground, sorry, from height above the ground, like the first two questions. So with this one, at this point, the velocity was zero.
Yeah.
The velocity was zero. And this is like two connected scenarios. So we've got a first case and a second case. If the final velocity of the first case, what's the relationship between the final velocity of the first case and the initial velocity of the second case?
Um, Final velocity of first case will be initial velocity of second case.
So if I'm looking at this side of the diagram, the particle was at rest. So u is equal to 0. The acceleration is actually coming down. That is negative 10. And the total distance over there is 31.25. So calculate for time over here. Calculate for the time for me. If you calculate for the time, you should get the same 2.5. If you calculate for the velocity, still get 25 meters per second. You get the same thing. So I'm going to solve the question using two different methods. Using two different methods. So there's one method. Have you confirmed the time for me, please?
Yeah,
Okay, so you can use x equal to ut plus half at squared, and that's
mm,
going to x equals to ut plus half at squared. U is 0, t is let's know. So s is equal to 1 over 2. The acceleration is negative 10, and the t squared is t squared. Sorry, s is 31.25. 31.25. So that's 1.25 t squared. So 31.25 divided by,
but how do I do square root of a negative number?
sorry. This acceleration is not negative. The particle is coming down. The acceleration is positive.
Oh, uh-huh. I didn't even realize.
Yes, the
Mm,
particle is actually coming down in this case. So the acceleration
mm.
is positive. Right. Why are you asking how can you take a square root of a negative number? Don't you know how to take a square root of a negative number? That
But
is going to
it's not, isn't it math error?
be complex numbers. Haven't you done complex numbers in maths, additional mathematics?
No.
Okay, then you'll be taught in pure maths that the square root of negative 1 is I. And
Yeah,
mathematics,
we have,
you were taught, right?
no, we haven't done that yet.
Okay, so square root of a negative number is I. This is called complex numbers. You'll be taught in pure maths 3, actually.
Mm.
Okay. Okay, so find the time for me. What are you getting for the
Yeah,
time?
it's the same 2.5.
The same 2.5. So you should take note of this now. Now that we've done this, I'm not going to do something like this again. At the time it's going to take the particle to get to its maximum position. So this is the same time it's going to take the particle to move from the maximum position to the level in which it was projected. So it is
Mm.
taking the particle 10 seconds to get to the maximum height. It's going to take the particle 10 seconds again to get to the position where it was projected from. Is that okay? So
Yes.
once that we establish that using another calculation, you don't need to do all this calculation. But I wanted to prove to you that okay, if you do the calculation, eventually you are going to get the same value. If you do that for the velocity, you are going to get the same thing as well. So again, we were asked for the total time. So and in answering the question, once you found one time, you can say that the total time is going to be two times of the time that we found already. So it's going to be 2 times 2.5, which is going to be 5 seconds. Or you can solve for the time for the first case, solve for the time for the second case, add a t, which is complete case of time. Or the last way to solve this is using a zero displacement. SUVAT, my Suvat. So I'm solving this question using a different way. We're given the initial velocity to 2.55.
Yeah.
And we're given, hey, yeah,
Hey, what? Wait. You was 25.
and the particle was projected upward due to the acceleration of negative 10.
You
The
said?
acceleration of negative 10. Okay. And
Yeah.
we are going to find the time that the particle uses to return to its original position. That was the question. The
Yeah.
time it takes the particle to return to its original position. When the particle is at its original position, what can you tell me about the displacement?
Zero.
So the displacement is 0. So use these three values to calculate for the time taken. Use the three values provided to calculate for the time taken and see what you're going to get. So again, I think you can use s equal to ut plus half at squared. S is 0, u is 25t plus 1 over 2 of negative 10 and t squared. Um, this is a quadratic equation. A is equal to 25t minus 5t squared and you can factor out t, actually
or
5,
even 5t. Yeah.
yeah, 5t. This is 5 minus t, and 5t is equal to 0, and also 5 minus t is equal to 0.
Mm.
So
So
it
t
gives
is
you
equal to 5.
t is equal to 0. Let me t is equal to 0 and t is equal to 5. So you can see I used different methods to solve this and I'm getting the same answer. That is the beauty of it. Now let's see if you can explain why t is equal to 0. Why do you think t is equal to 0? What does it mean?
Um, I think they are doing initial and final time. Oh, I don't.
Okay, it's starting initial and final time. You see, when a particle was at this level, the time hasn't started. When a particle was at this level, the time hasn't started. So the time over there was 0. When the particle started, there was another time, which is 5. So that is the meaning of the time equal to 0 and time equal to 5. So at this time, the particle hasn't started. It was at the same position as the particle being at the same position at this point. So the calculator or the calculation is telling you that, okay, there are two possible values for this to be at the same position. The first possible value is 0 when the time has not started. And the second possible value is 5 when the particle is at its original. So this is a nice question. You can go with any times. I would like to go with the zero displacement. I normally go with the displacement. But if you like, you can go with the calculating the time that the particle gets to the maximum height and you multiply it by 2 because the timer is going to be the same. Or if you feel like you want to write more, there is this guy that I was in class with. There was this examination that he didn't really know, and he wanted to give the impression that he knows what he was writing. So one short method, the person makes it a very long method. So you see the person busily writing, but not really doing anything. So you let someone see that you are busily writing. You solve it using two, like solve the first time, solve the other time, knowing that you are going to get the same thing. Then afterwards, add the two. But that is complete waste of time. Unless maybe you don't know what you are doing. You can't solve all the questions. The only question you can solve is question 2. And you don't want people to see that you can't solve all the questions. So okay, so that's for that question. Let's see what we can do about question number 6. Question number 6. Let's see if we can crack this for me. A stone is thrown vertically upwards at a speed of 12 meters per second from 5 meters above horizontal ground. This is also falling under the first scenario. Find the speed at which the stone is. Find the speed at which or with which the stone hits the ground. That's interesting. I know the answer is going to be 12. The thing was projected, and the particle is going to come down again. So it's going to come down using the time it traveled to reach the maximum height, and it's going to come down with the same speed.
Speed.
So I know the answer. The answer to this question is 12 without even calculating. I know it's 12.
So
Uh,
the speed will even be the same, even if it exceeds the 5 meter.
yes, we can go back to the other question. Calculate the speed. You notice that you're going to get the speed to be 25 meters per second. So you calculate the speed over there. It's going to be 25 meters per second. It's the same thing. So I know the answer to this is going to be 12 meters per second. But let's solve it anyway. Let's solve it anyway. Let me use this. Okay. So let's look at the Suvat. Suvat. The initial velocity given to us is 12. The particle is thrown or is projected upwards vertically up. So the acceleration is 10. Um, for 5 meters above. Oh, okay. This the speed is not going to be. The speed is not going to be 5 actually. This is scenario two. This is
Yes,
scenario.
scenario two. Yeah, that's what I was asking then.
This is scenario two. So let's solve it for the speed is naturally not going to be that. I saw the question to be a scenario one question type of question. Okay, so let's say this is 5 meters above the ground, 5 meters above the ground, and that's where the particle is at. The particle is projected upwards, vertically upwards with the speed of let's go and gets to a level with a speed of 12 meters per second. 12 meters per second. And actually, in real life, there is something like it's very difficult to get a very straight vertical motion. It's very difficult to get something like that. So, what you actually come across will be projectile motion, and that is mechanics, further mechanics. But anyway, let's deal with the vertical motion. So, what I'm actually doing is actually representing projectile motion. But let's assume that it's vertical. Okay, it's vertical. Going over there is actually projectile motion, but let's assume that it's vertical. Okay, so this was the speed at which it was projected. 5 meters above the ground. Find the speed at which it hits the ground. There are two different ways to solve this question. Two different ways to solve this question. A lengthy way and a very short way. Let's go to the lengthy way first. Let's suffer small. Okay. So what do you think you do? You want the speed at which the particle gets to the floor with. So it travels and comes to the floor. You want the speed at which the particle gets to the floor with. So the speed. What any ideas as to how to solve this question? There are a lot of ways to solve it actually. So give me one. Let's think about one.
Okay. Um, can I see that displacement to be zero?
You know, the displacement actually won't be zero. I like where you are going. See where the particle was projected. And is the particle up its point of projection or down its point of
Okay.
projection?
-5.
Then that is the short way. Then the short way is that the so one that you started with displacement. Let's continue with the displacement. The displacement over there is going to be -5 meters. -5 meters. So we've got three values. You can now solve the question. Later we'll use the lengthy way to solve the same
Okay.
question. So the lengthy way would be first calculating for the distance it gets to its maximum height. Then I treat this question as a scenario three question. Are you getting me? So I'm
Yeah.
combining scenario one and scenario three. So I treat this one as a maximum height. I find the distance, it gets to the maximum height. Then afterwards, I add this distance to the five and I treat it as a scenario three question and find the that to answer the question. But it's a lengthy process. You can solve it that way anyway, so that you get a variety of ways to solve a particular question. Now, looking for velocity, you can use v squared is equal to u squared plus 2as. V squared is equal to u squared plus 2as. And we don't know v, so v squared is equal to u squared and squared, that is 144, plus 2as. 2, the a is -10 and the s is -5. So you do your manipulations and you should
Yeah.
get
V is 15.6.
v is equal to 15.6 meters per second. Okay, let's solve this using the long way. Let's solve this using the long way. Is that okay with you?
Yeah.
Okay. Same question. First, let's find the maximum height of our skull reaches. So with this one, we first need to treat it as being projected from a level ground. So I'm treating this as a type one. So this is actually my level ground. So let's find the maximum height. Let me set up the Suvat over there. Suvat, we know the initial velocity to be 12. We know the final velocity, maximum height, the final velocity is 0. Just to be 0. And this is moving against gravity. So this is -10. I can find s with this one. Using v squared is equal to u squared plus 2as. V squared is actually 0 squared, and U squared is 144 again, plus 2AS. 2, the acceleration is negative 10, and S is S. So calculating for L, what would you get? I think you are going to get 144 divided by 20.
Neg- negative 7.2.
And that should be equal to 80. And negative 144 divided by negative 20.
Oh, so 7.2
7.2. 7.2 meters.
meters.
Plus, the distance that has got travel from this side to this side is 7.2. This is 7.2. So the next part of the question, I'm going to treat this one as a scenario 3 type of question, where my final velocity of the case 1 becomes the initial velocity of case 2. So let me change the ink for this one. So Suvat again. The initial velocity over there is going to be 0.
I said if we were doing it that way, wait, okay, you are doing it in 3 stages.
2 stages actually 2. I can do it in 3 stages actually. I'll find that first, then I continue. It's just going to make the thing lengthy. I can find the same thing using 3 stages. So what I'm doing now, I'm using 2 stages.
It's in 2 stages.
I'm finding the maximum. I found the maximum height, that is 7.2. That's what it gives me.
Yes.
Now I'm going to treat the question from as a scenario 3 question. For a particle is being dropped at this level to the ground.
Okay. The ground.
So that is 12.2. That is the total distance, 12.2 meters. And at this point, the particle was at rest, so U was equal to 0. The speed is what we're looking for. The acceleration is going to be a positive 10 because it's moving downward.
Mm-hmm.
So
Yeah.
let's use V squared is equal to U squared plus 2AS. V squared is V is actually what we're looking for. U is 0, and 2 times we'll do the manipulation and let's see what you get. The square root of
That's 15.6.
so V is equals 15.6. So you can see the same thing we got in the short method.
Okay.
Most people would like to use the acceleration, sorry, the displacement method. It's the shortest method you can ever come across. That's why I told you earlier that I normally use the displacement. The reason why most people wouldn't use the displacement is it's very easy to get it wrong. If you don't pay attention to the signs, if you use a positive sign for the 5, you would have gotten it totally wrong.
Mm.
So majority will go for okay, let me go through this process and come down. It's complete waste of time. So you can solve this using another way. You find the speed at this point, then you continue. It's just complete waste of time. So please always be very careful. When you're using the displacement method, you should know what displacement is. When you're moving upwards, it's positive. When you're coming downwards, it's negative. And the particle at this point, the displacement is 0.
Yeah.
And the oranges. Once it gets past this stage, then it's moving backwards. It has now like moved backwards 5 units. And if the object has moved backwards 5 units, it implies the displacement is actually negative. So that's what has a negative displacement. And just these 3 values, you get me the same answer I got going through this step and this step. So you just need to.
So the first one that we did is simply like finding the displacement from the yellow side to the black side.
Yes, actually, yes. Yeah, this side to this side. Okay, so with this one, we're told to find the time taken for the particle to hit the ground. So again, this can be found using a lot of ways. Someone can decide to find the time it gets to the maximum position, and multiply the time by 2. That will get you the time it got to the side, and treat it as type a scenario 3 question, and that That is going to waste time. I don't like time wasting. I don't like time wasting. Meanwhile, you can use this one and find your time straight away.
Yeah.
Are you getting me?
Yeah.
Okay, so use that one and find the time straight away.
Mm.
And with this one, get ready because I'm going to ask you to explain why the time is negative and positive.
Okay.
So you can get one answer of the time to be positive and one answer to be negative.
Okay.
And you should be ready to explain why one is negative. I know you're going to take the positive and leave the negative, but you should be able to explain why one is negative and one is positive based on the explanation I gave you earlier.
Okay.
Either with the time.
Yes.
So you can use uh okay, once I know the V is correct, I can use V equals U plus 80. I was trying to avoid the V. Like I told you the other time, try your possible best to do all the values you calculated for
Mm.
so that you minimize your error rate. But since I've used two different methods and I'm getting the same thing, I'm going to use V equals U plus 80. So V equal to U plus 80. But actually in examination, I won't even do that. Nah. I like math so I always want to get every possible mark over there. And me is 15 points. Is it? This is even going to worsen the case. This is not going to give us the answer. Yes, yes, yes. This is going to give us the negative answer.
Yeah, sure.
This will be a favorable equation to use. I know you're going to get one negative and one positive. So use what's it?
S is equal to UT plus half
Yeah,
AT square.
because UT plus half 80 squared.
Mm.
Yeah. And get ready to explain why one of the answer is negative and one of the answer is positive.
Yeah.
Have you gotten the answer?
Yeah.
Yeah, we are now thinking about which one, why is one negative and one
Yes.
is okay. Should I come in or you like to do something about it?
Let me see.
Okay, okay. Yeah, try and see if okay. Let me let me take it. Let me go back to the previous example. Was it okay? This was the previous example.
Yeah.
See, this explanation I gave. Both particles, the particle was at one same place at two different times, right?
Yeah.
This particle was at this time when time was equal to zero, and this side when time is equal to 5. So the particle was at the same level at two separate times. Looking at this one, the particle was at this level only once in the
Oh, so,
journey.
mm,
Are you getting me? So
yes.
it was at this side only once. So there is only one possible value for t. So there is one possible value for t, and
Mm.
that's why we are getting one to be positive and one to be negative over there. Assuming the particle started at this point, we are going to get two positive values for t because the particle was at this 2 points at two different times. But with this one, whenever you get a negative time, it means that at that point the particle was in there two times, like one is positive and one is negative. It
Mm.
implies the particle was only at that point in one point in time. But if you get two positive answers, it implies that the particle was there at this time, and at the same time, the other time the particle was there. I'm using time. I don't know if you get what I'm saying.
Yeah, you understand.
Again, if you find the time the particle got to the side and the time the particle got to the side, you're going to get two different times. One, all of them being positive. So when one is negative and one is positive, it means that the particle was just there only once. But when both are positive, on two different oceans. Okay, so that is the explanation to that. No one is going to ask you to explain this, but it's good to know.
Mm.
At least it makes you check your work when you are going astray. And I really love this course. Like the practicality of the course makes me love it because you can use it in a lot of areas. And I would like my students to learn, like know what they are doing, not just because the maths involved. After all, we just want maths. So let's do this and get our marks and go. Like,
Mm.
learning mathematics that way makes it boring. Okay, let's see. Oh, this looks very innocent. A ball is dropped from my 30 meters. Find the time again. Derek, you're too going for this question. You agree, right? Like there's
Yeah.
a time. Yeah, you too going for this question. Let's move on to another one. Okay, so this is more like it. A ball is thrown vertically upwards with an initial speed of who does that? Who even tells you that this initial speed? This is actually an easy question. An initial speed of 8 meters per second from height 1 meters above the ground. Find the time when the speed of the ball is zero. What other way can this question be played? Derek, find the time when the speed of the ball is zero.
Um, find the time when the ball reaches its maximum
Very good.
height.
Okay, yeah, that is very true. Then greatest height reached. Find the speed of the ball when it hits the ground. Okay. So you don't really need to sketch the phases. Okay, you don't really need to sketch it, right? My humble advice would be that just try to sketch it. You won't lose any score if you sketch it. It's actually going to guide your solving process. In the marking finger, it's something like sketching over there. That's something like sketching. Unless you are sketching, those kind of placement and velocity time graphs and other things. No mark is allocated for sketching, but it's a good practice. At least it makes you visualize what is going on, and you can take it up from there. Okay, so this is done with a velocity of 4 meters above the ground and a velocity of 8 meters per second. So I can set up my Suvat nicely. So with this one, my final velocity is 8. The final velocity was 8. The acceleration is -10. So you should be able to find, or should be able to find T and U. Sorry, T and S.
Yeah.
Yeah, now V equals U plus 80. V equals U plus 80. But do you know the V equals U plus 80 showed me the other time?
It will.
Showed me the other time.
Yeah, when we go to the
Yeah.
negative term.
Actually, this is my first time that it has failed me. But it's still my favorite. Okay, so this should be 4/5 seconds. So I think 0.8.
Yeah.
0.8 seconds, yeah.
Yeah.
It takes after 0.8 seconds to get to its maximum height. So 0.8. The next question tells, I think, said we should find the height above the ground reached by the ball. So again, I can find S using S equal to anything about 30 use V plus RKT squared. Or no, I won't use a T. I'm going to use V squared
Yeah, v square is equal to u square.
v squared plus 2as.
Yeah.
So that in case that t is wrong, I get myself this mark and lose the other mark. The a is -10 and s. So -64 divided by 20.
Yeah.
So 64 divided by 20.
No, negative 20. Oh, okay, yeah, yeah, the same thing. That's 3.2.
Okay, so s is 3.2. But does that answer the question?
They said the greatest height above the ground reached by the ball. No,
Up, down, leave the ground.
the ground is down there, so we have to add the 1 meter.
So the total height is so from it gives me 1 plus 3.2. This is 4.2 meters. 4.2 meters. Okay. Now find the speed of the ball when it hits the ground. Let's stick with displacement. Okay. I don't want to go through that long process.
Okay.
Let's stick- so let's start off the Suvat again.
So for
What is going to be the displacement when it gets to the ground?
um -1.
That is very good. It was projected upwards.
Yeah.
What is the acceleration?
It was projected upwards, but now it's moving down, right? So it's
No, no. Just it was projected upwards. That's all. -10.
and so you only use like the one that you don't think of it. Okay, we are looking for the total speed throughout the whole day. So
As taking care of the displacement. So we're just looking at it going upwards. That's why I said I was like this method. Most people won't like it, but if you don't take care, you're going to mess things up.
mm,
So just looking at the scenario where it's going up, it was projected upwards. That was the question. That should be the question you should ask yourself. Okay, was a particle projected downward? And interestingly, I don't think it's going to be projected downward and get back up again.
yeah,
So
yeah, sure.
it can bounce. It depends. If a ball, the attacker can just the ball and it hits the ground and bounces back. Will it even pass the level at which? Well, that's something I have to think about. Are you getting me? Like there is a ball, you drop the ball, and the ball hits the ground, and the ball bounces to pass at the level at which it was dropped. If you don't apply any force to drop this ball, I don't think it's going to bounce past this level.
Okay, yeah.
Okay, so the velocity as we this was projected as 8, so we can use this three values to find t. Using v squared is equal to u squared plus 2a, as you should be able to find t. So with this one, v squared is equal to u squared plus 2as. This will be v squared, the u is 64, and the a is, writing a positive. Let me just write a negative. How am I copying this? Negative, it's still a positive,
Yeah.
20s.
Um 9.62.
Okay, so v is equal to 9.62.
Okay. No, 9.2. Yeah, 9.2.
9.2. Okay, so there are times in the laws of motion when we start doing connected particles. We actually will come back to this. Connected particles has got a lot of things to do with the free fall. So if you understand this free fall, then my work over there will be very, very simple. If you understand the free fall.
Mm.
Connected particles, at times the question will be like find the speed at which one particle is the ground. And it turns out that you are getting the negative velocity. What do you think you're going to do to the speed?
It will, the speed will still be the same, or like just that it will be moving the opposite direction.
No, you're not getting me.
How?
The question and the question says find the speed. Because there are two different particles, you get one speed to be negative, negative, let's say 3 meters per second. And the question says find speed. Will you leave the answer this way?
I don't understand the question.
The question says you should find speed, right?
Mm-hmm.
And
Yes.
after calculation, you got this one to be negative 3 meters per second. Let's say that this is correct. I
Yes.
used to answer this way for speed. Yeah, I'm not
Yes.
getting the question. I'm just trying to tell you speed can be negative
So you have
because
to write
this
it
is
in a
velocity.
positive form.
Yes, this is velocity. The velocity is negative 3 meters per second, but the speed is three.
Ah, okay, okay, yeah, yeah, I understand. I
Yeah,
just
the
got
speed
it.
is three. The speed
Mm.
is negative 3 meters per second. Okay, so these people will just try to trick you, but it should be fine.
Mm.
Question number nine. Question number nine. A ball drops from earth from top of building. At the same time, spin through. Wow, hey, this was what they did in the and your seniors past question. They combine free fall with momentum. And the way they stop it, like they combined free fall with momentum, and it was a little bit difficult. It was difficult actually. It was difficult. It requires a little thinking. So let's see what we can do about this one. A boy drops a ball from rest from the top of the building. At the same time, a friend throws a ball vertically upwards from the base of the building at a speed of 30 meters per second. The two balls collide after 8.1 seconds. Find the distance from the ground to the top of the building. When we talk about collision, there is this thing also that comes into play, momentum. So they combine the question like that. You can check the 2020 mechanics paper, 2020. Question number six also. The question was very interesting to the extent that like I was eager to solve the question
Mm.
because of my shakos. They were like this question was difficult. By that time I wasn't teaching mechanics actually.
Mm.
I was handling this guy in the shark team. I don't know if you know him, Bona.
Yeah.
Yeah. It was like, hey, Sema, the question was interesting. So I was just waiting to solve the question. And indeed, it was interesting. Very interesting. Hmm. Any ideas as to how to do this one?
Okay, I know we have two cases.
Yeah, that is very good. We've got two cases. That is very good. Let's try to visualize things now. Okay.
Okay.
So there's my ground. There's my ground. A flat surface. Let me use blue for my top ball. So this the ball the boy is dropping. Let me use this ball for the black for the ball don't vertically upwards. So this is going upwards. This is coming downwards. This is interesting. Now, if the height of the building is
Yeah.
let's say 10 meters, uh and they collide at 7 meters above the ground, how
So
far?
where did you see the? Oh,
Okay,
you are just giving
so
an example.
this is an assumption.
Ah, okay.
Trying to bring one or two things together. So
Okay.
the blue ball was projected downwards, the black ball was projected upwards.
Mm.
Let's assume that they collide at a distance 7 meters above the ground. How far would have the black ball traveled?
Three. Either
So
3 or 7.
they collide over here. Let's say they collide at a point 7 meters above the ground.
Above
So
the ground. So the black ball will travel 7.
and the blue ball would have traveled.
3.
Similarly, let's say they collide at 2 meters above the ground. How far would have the blue ball traveled
8.
and the black ball?
2.
Good. So if the distance is h, how far would the black ball travel?
Um.
The distance above the ground after they collide. Okay. Let's set up the Suvat.
Okay.
Let me set up the Suvat for the blue ball first, and we come back to this one. So let's use the information we've got. What is the initial velocity given? I think this one was the blue ball was drawn from rest, so zero.
Yeah.
Uh, the acceleration. This is coming downward, so the acceleration is actually positive, 10 meters per second squared, and they collide 1.8 1.8 seconds. Oh, okay. Let's set up the silver for the black one. So Suvat. I think we've got a value to calculate this. There's three values over there. Let's try finally. The speed of reaction was 30. It's going upwards. The acceleration is negative. The time is 18. Sorry, 1.8.
Yeah.
So the if the blue ball has traveled X meters, the black ball would have traveled how many meters? First, let's calculate
Okay.
the distance traveled by each object. So calculate the distance traveled by the blue ball and the black ball.
Okay.
You can do that for me, right?
Yes.
Okay.
Okay. That's 16.2.
So is it for the black or for the blue?
That was for the blue.
Okay. 16.2.
Yeah.
Okay. And for the black,
For the black, I'm coming to do that. Um, 45.
45.
Yeah.
45 meters. Okay. So let's come back to this one. Assuming we don't know the
Wait, I
total.
think
Okay.
87.8.
That's 7.8.
Yeah.
Okay. I'm not calculating, so please be very sure with the answer. That's 7.8. Okay, so assuming we don't know the height of this one, we don't know this one, and let me just clean it all together. I'm doing it with dirty way, and I'm saying that okay, this two particles collided at a point. They collided at a point 7 meters. This traveled 7 meters, and this traveled 2 meters when they collided. What is going to be the total height of the building? Let's say
9.
this traveled 5 meters and this traveled 7 meters and they collided. What is going to be the total height of the building?
12.
12. How did you get a 12?
And 5 plus the 7.
5 plus 7. So there's actually the same case over here. The particle traveled 16.2. The question was actually easy. 16.2 meters, and this also traveled 37.8 meters. So the total distance traveled by each object, the total height of this is going to be 16.2 plus 37.8, and that should give you an answer. I was looking at a more difficult scenario, but this question was actually easy.
Hmm.
So do that for me. What is going to be the answer to that?
54 meters.
4 meters. Okay, that is very good, and that answers the question. That was the question, right? The two
Yeah.
balls collide 1.8. Find the distance from the ground. So the total distance is 54.8. So at times you just need to put in some small thinking. And this question was easy because the in both cases we have provided three Suvat values, and
Mm.
you being given three Suvat values, you should be able to work around with that and get something nice.
Mm.
Okay. Let's see how many questions have we solved so far. Okay. Let's solve the tenth question. I've got three more to go, but I think time is not on our side. So
Hmm.
let's solve this one. The ball is thrown vertically upwards from the point O at a speed of 30 meters per second. Find the time the ball is at height of 24 meters above point O for the first time and for the second time. Oh, this is nice. This is nice. This is nice. This is nice. There are two. Let's say there are three ways to solve this question. There are three ways to solve this question. So attempt it. Or maybe use a difficult, not a difficult way, a lengthy way to solve it first. Then uh, we look at a shorter way to solve it. And Derek, let's think this one through. From the explanation I've given you so far, what do you think the time is going to be? Assuming you got a quadratic, you solve this and get a quadratic equation. Is one going to be positive and one going to be negative, all negative or all positive?
I'm coming. Is it?
I'm saying that assuming you solve this and you come across a quadratic equation, are you getting me?
Yes.
Are you going to get a value for t that is one negative and one positive, all negative or all positive?
Won't I just get one answer because they said above point O, so it hasn't yet reached that
Mhm.
side. Oh,
A ball is thrown
so
upward,
okay, both positive. Mm.
both positive because we clear at a point that 25 meters at two different times. At two different times. So both answers will be positive. But solve it anyway. And is there a case where the answer will be both negative? These are some of the questions you should be asking yourself. Is there a case where the time is going to be both negative? Actually, there are lots of cases where the time is going to be both negative, which means that the question is not really set well.
Mm.
Um, an example would be, let's say that a ball is projected from this side and it gets to this side in about 5 seconds, and the maximum, let's say the maximum height the particle reaches 5 meters. And if I tell you to find the time the particle goes to the height of 6 meters, the particle will never get to height of 6 meters if the maximum height is 5 meters. Are you getting me?
Yeah.
In this case, the time is going to be both negative because the particle will never get to that 6 meters over there. So there are cases where this, but you won't get that in your examination. But it's good to know. It's good to know so that when you solving and you get something like that, you should know that hey, there is something wrong somewhere. And this is called success criteria. So are you done?
Yes.
The yes is not confident.
Because I was still writing also.
Okay.
Okay, I got C as 5 and C as 1.
Okay, 5 and 1.
Yes.
Okay, let's solve it. Let's see if we can solve it using a lot of methods over there.
I
Uh,
said, does that answer I and I?
yeah, the answers are in I.
Okay.
Let's use a long method. So, uh, setting up the Suvat, the acceleration is -10. It was shown vertically upwards with a velocity of 30 initial velocity. Is that defining the time 5 meters above using uh, f equals u plus 80. Or if I use f equals u plus 80, I'm not going to get the time to be 2.
Yeah. Right, so I use S equal to UT plus half AT squared.
Hey, did I say f equals u plus 80? What am I
Yeah.
talking about?
So V.
Yes, yes, yes. Okay, so this one is actually straightforward. It's it won't worth it using two different methods, ut plus half 80 squared. S equal to 25. But Derek, are you getting why you are getting two different positive values? That is very
Yes.
important. Yes, okay. And again, um, yeah. So for all you know, this can be another interview question. Is it possible to get two negative times when solving the question? And if possible, why? If not possible, why? You remember one of the interview questions I shared with you?
Yeah.
The displacement. Okay. I got the place anyway. That was the place I was talking about.
Mm.
I had to decline for one or two reasons.
Okay.
Okay. So you solve this one and you get two different times. P is equal
Yeah.
to 1. So the basic explanation is that when the ball is projected at 25, once it's going to get to its maximum height and come down, this point there is a time recorded, and at this point there is a time recorded.
Mm.
Okay, so someone can decide to find the time at the side. Now find the total height. Like it's going to be an empty place.
Mm.
If you try to divide the workload, you actually stretch yourself. But some people think that one is easier. Well, everyone is entitled to it or opinion, but I will never do that
Mm.
actually. Wait, if you've got mastery over the subject, the content, you can manipulate your way around things. But if you are not so strong, that is where you start to do things that you are not supposed to do, and to just waste your time.
Mm.
Mind you, got 1 hour 15 minutes to write this paper, and for 50 marks. Okay, so find the total time, de facto. Find the total time that the height of the ball was above 0. So what do you think this is going to be?
Wait, find the total time that the height of the ball was above point O
Mm-hmm.
is at least 25. So they just want me to find the T. So I can use the same.
No, 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 no. This one
Wait,
I'm not going to the CP. Boy, big man, you got CP, you got 1 and 5, right?
yes.
So at this point, which side represents the 1 second and which side represents the 5 seconds?
The first one represents the one. The second one represents the five.
This is 1 second, and
Yes.
this is 5 seconds.
Yes.
5 seconds. And the question is asking you, for how long was the ball above this level? The ball was actually above this level for 4 seconds.
Oh,
Five
I don't
minutes.
know the way they pose the question.
Okay. So it's basically telling you find the time that the ball was above 25 meters. So at this point, at 1 second, it was at 25 meters. At 5 seconds, it was at 25 meters.
Mm.
So this area.
Okay.
So that gives you 4 seconds. That is actually very simple. Someone can find the time from this side to this side. The time, like I mean, the time from this side to the side.
The time from the other side to
Then you subtract a time from this side to this side. Then you multiply by two.
mm,
So like you can do a lot of things with this one. It depends on the person solving the question. I wouldn't do that, but if you do that, it's not wrong either. Please take a screenshot of this question.
okay.
Actually, in your book, question 11, question 12, question 13. So
Okay.
there's everything is in your book.
But it's not numbered like that. So let me just take it.
It is numbered this way. It's numbered that way.
It's numbered that way.
You can check question 11, question 12. That one the summary exercises. It's I think one of the before the summary exercises.
Okay.
Yeah, it's numbered that way. This time I took the numbers also. Okay. On Thursday we'll be solving past questions. Some crazy past questions. So get yourself ready.
Mm.
And after the past question, you should know that we're done with everything. The second topic
Mm.
and the laws of motion. You can read around the laws of motion. The first law, which you're not going to do enough. You're not going to really do a lot when it comes to the first law. The second law, yes, the second law, we do a lot of things with the second law. That is F equal to ma. So we started using that. I don't know if you remember during the friction, force equals mass times acceleration.
Yeah.
So change and blah blah blah. So read around the laws of motion also. And the third law will come into play when we're dealing with momentum. So especially when I'm trying to derive the conservation of momentum, where it says that the initial momentum is equal to final momentum.
Mm.
Yeah. So yeah, that one can take me about 3 weeks, 2 to 3 weeks. The second law, not the second law, the laws of motion. Then I use 1 week to do the momentum. Then work, energy, and power. I don't know if we'll be meeting in school. I don't know, but if we'll be meeting in school, we will take it up from there
Mm.
also. So that is that for today's class. It has been fun at least. I wasn't in my first mood, but at least yeah, Charlie, I'm better now. Okay, so thank you very much for your time and taking care of yourself.
Yes, sir.
And I'll be posting the videos. I don't know. I've been lazy of late, but I promise I'll post them before the close of this week. And also when you go, you can you can write them to your video in
Yeah.
case they are not really like they want to do extra learning or something.
Mm.
Okay. So take care of yourself for me. We'll meet on Thursday. Bye.
Bye.